Welcome to this video on What is Machine Learning, presented by Professor Manish. Machine learning, or ML, is a subfield of artificial intelligence that enables computers to learn patterns from data and make decisions without explicit programming. Unlike traditional programming, which uses rules and data to generate output, ML systems learn rules, or a model, from data and output. Artificial intelligence, or AI, is a broad field of computer science focused on building systems that simulate intelligence. In simple terms, AI allows machines to think, reason, learn, and make decisions like humans. Examples include problem-solving systems, natural language understanding, and vision systems like face recognition. The core idea of the relationship between AI and ML is that AI is the goal, and ML is one way to achieve it. AI aims to make machines intelligent, while ML specifically focuses on letting machines learn from data to become intelligent. ML is a subfield of AI because AI includes many approaches, such as rule-based systems and logic, and ML is just one of these methods. Furthermore, ML is distinct because it focuses on data-driven learning, using data to automatically learn rules, in contrast to traditional AI, which relies on handcrafted rules. Consider the problem of email spam detection. An AI rule-based approach might flag an email containing, quote, free money as spam. An ML approach, however, learns from thousands of emails to automatically detect various spam patterns, making it more powerful and scalable than a simple rule. Comparing AI and ML, AI is a broad field focusing on intelligent behavior, using rules, logic, and learning. ML is a subfield of AI, focusing on learning from data through a data-driven approach. Examples of ML include neural networks and regression models. A final insight is that AI represents the complete system, such as a diagnosis pipeline. In this analogy, ML acts as the core engine, utilizing specific models like CNN, LSTM, or QSVM to drive the intelligence. The Turing test was proposed by Alan Turing in 1950 to determine if a machine can exhibit human-like intelligence. It involves an interrogator communicating with both a computer and a human, attempting to distinguish between them. The test includes 3 participants: a human judge, a human participant, and a machine, or AI system. The goal is that if the judge cannot reliably distinguish the machine from the human, the machine is said to have passed the Turing test. In summary, AI is a complete system aiming to replicate intelligence. ML can be seen as the vital component or engine within that broader AI system. The Turing test is important in AI because it answers a fundamental question: can machines think or behave like humans? It tests behavior based purely on output, focusing on natural conversation and human-like responses, without needing to understand the machine's internal workings. However, the Turing test has limitations. Imitation is not equivalent to intelligence, as a machine might mimic responses without true understanding. It's also a narrow evaluation, testing only conversation and not vision, reasoning, or learning depth, and can be tricked by vague or misleading AI answers. Machine learning can be viewed as an extension of statistics. Its goal is to learn patterns, relationships, and predictions from data, using probabilistic and mathematical models. The core idea is that ML equals data plus a statistical model plus optimization, using probability theory and statistical inference to learn from data. The statistical view of ML assumes data is a random sample from an unknown distribution, and ML estimates this distribution. A model is assumed as a function, where learning involves estimating the best parameters for that model. There is a strong connection between ML concepts and statistical concepts. For example, training data in ML is the statistical equivalent of sample data, and an ML model is a, quote, statistical model. ML is often called statistical learning because it learns from data distributions, uses probability models, and applies inference and estimation. It also optimizes the expected error. The final insight is that machine learning is a statistical approach. Models are trained using data to estimate underlying patterns and make predictions by minimizing error or maximizing likelihood. Thank you for watching this video. We hope you gained a better understanding of the connection between machine learning and statistical concepts.